Hello everyone, my name is Kapil and I'm working as a civil and structural engineer with MIDAS IT. I welcome you all to this online session on introduction of MIDAS nGen. In this session, we will see about MIDAS nGen, which is the latest structure analysis and design software released by MIDAS IT South Korea. This software is based on a new concept for structural engineering. Since this is an introductory video about MIDAS nGen, we will see that what is the basic concept of this software and what is the basic idea on which this software is developed. This software upgrades the existing technology for structure analysis and design, and it makes the work of structural engineers a lot more easier. MIDAS IT has always taken a lead in developing new solutions, innovative solutions for structure analysis and design, and by developing nGen, MIDAS has maintained that lead. In order to understand the basic concept of the software, we will model some basic structures in this software, and we will see that how this software helps the engineers in very detail and at every step. How this software will actually make the work of engineers a lot easier and will enable them to do their job more quickly and more easily. At the end, you will be able to appreciate the new innovations that helps the user to do their things more quickly and more easily. Let's begin our session now. Since this is a new upgrade in the existing technology for structure analysis and design, let us see that how the technology for structure analysis has been developed so far. So the era of structural engineering started with experiment-based understanding. If we wanted to model some structure, we actually used to create the prototype models, and based on the result of the prototype models, we used to extrapolate the results and understand the behavior of actual structure. But then after this, the force-based methods were developed. Various methods such as moment distribution method, slope deflection method, they enabled the engineers to do some hand calculations and understand the behavior of the structure. They used to provide very good results about the deflection of the structures and about the moments and the stresses of the structures. And then the stiffness based methods were developed, and in order to solve the stiffness based methods, hand calculations or binary calculators were used. And then as the structural engineering integrated with the computer softwares, the metric based softwares were developed. So we used to input the stiffness of the structure in the form of some matrices, and the computers used to solve those matrices and provide us the final result about the displacement and the forces. And then 2D softwares were developed where we were actually able to model the node and the elements. And then we used to assign stiffness to these elements, but then the programs were upgraded and we were actually able to directly input the section into the software, and the software was able to calculate the stiffness by themselves. And then 3D softwares were developed for node and elements, and these softwares were very common, and even today a lot of node element based softwares are being used in the market. And then the latest upgrade in the 3D softwares is the object based platform, which actually help us to get rid of dealing with node and elements, and they actually allow us to deal directly with structural elements like beam, column, wall and slab. And then the limitation of these object based platforms is that they are limited to regular structures. So if we have to model a very regular structure, then it is very easy to do in the object based platforms, but this limitation has been removed very effectively by MIDAS nGen. So MIDAS nGen actually provides us an object based platform for each and every type of structure. So for regular as well as irregular structure, MIDAS nGen provides us an object based platform and helps us to do our job more quickly and more easily. So just to explain that what is the difference between the node element based software and the object based software, I have prepared this slide. In the node element based software, we actually create the nodes to start our structure modeling, and then we join these nodes And then we assign the certain section properties to these elements, and the programs perform the analysis and design based on these elements. But in the object-based softwares, we actually don't need to model any nodes or any elements. We directly model the geometry, we directly model the columns and the beams. And then the software analyzes this geometry based on the meshing of the geometry. So in the object-based platforms, we are not dealing with any nodes or any elements. So the program will further create the finite element model based on the geometry that we input. So in this way, node elements and object-based interface, they are different and they provide us a different working environment, and both of them have their own advantages. So today let's focus on this object-based platform. And as I mentioned, that MIDAS nGen allows us to work on regular as well as irregular structures. So MIDAS nGen can be very easily applied to modeling and design of RC buildings. So if you have a RC building, you can model substructure as well as superstructure in your model, and you can use it for analysis and design. And if you're dealing with a steel building, then you can use MIDAS nGen, the same environment, and you can model the structure quite easily. MIDAS nGen can also be applied to the plant structures. There are very good features which are actually very helpful for the modeling and analysis of the plant structures. We'll see a few features in the coming slides. And then finally, if we have irregular structures, so for example, if we are dealing with underground structures or underground subway stations, water tanks, then we can actually use MIDAS nGen very easily and based on the object-based platform, and we can analyze and design structures quite easily. And moreover, if you have a structure in which you have RC as well as steel members, if it's a mixed construction, then you can use MIDAS nGen, and in the same environment, you can model, analyze and design the structures integratedly. So it supports all the type of structures. The concept of nGen, or I'll say the basic idea of MIDAS planning team while developing this software, was to provide an easy to use software for the engineers, to provide an integrated platform for the engineers for regular as well as irregular structures. And the software supports the entire work of a structural engineer. So if you bring in the data from architects in the form of architectural drawings, you can directly import the architectural drawings into the software and quickly generate the model based on the architectural drawings. You need not create any section sizes manually, or you need not create the offsets manually. Everything can be done based on the architectural drawings, and then you can proceed with the analysis as well as design. You can design RC as well as steel members. For RC members, you can design as per RC beams, RC columns, RC walls, RC slabs. Slabs can be of plate or of membrane type. And then you can generate the reports quickly. Analysis as well as design reports can be generated very quickly. When the project reports can be generated, there is an in-house word processor for that. And then you can take off the quantity, and finally you can take off the structural drawings, and you can integrate the entire procedure from drawings to drawings. So let us see that what is the workflow in MIDAS nGen and how does it help us to use the various workflows depending upon the type of structure we are dealing with and depending upon the preference of engineer who is using the software. So MIDAS nGen actually offers a CAD based modeling method. We need not actually create the nodes or the elements in order to generate the elements. We can just do it based on the CAD based features. So various options like extend, trim and offset, they are available in the software, and we can do the modeling which is based on the grid lines. So we can generate the model based on the grid lines. We can generate various types of grids, and we can generate the geometry quite easily, and we can generate the data with grid and without grid in one model file, so that provides a lot of inconvenience for the irregular structures. So in one structure, you can have the various columns which are located at the intersection of grid lines, but if you need to create a column where you cannot generate a grid line, then you can even generate a column without the option of a grid line. So that's how MIDAS helps in providing you more convenient option. And if you have an irregular structure, then you can generate the geometry quickly in MIDAS. You actually don't need to import the geometry from AutoCAD. You can generate the geometry quickly into MIDAS nGen. So for example, for this structure, you can model the geometry using the extrude as well as the Boolean command, and then you can auto generate the members and the program will perform the meshing for you. So you can just change the meshing size and the program will change the analysis results accordingly. So the finer the meshing, the more accurate the results will be. And as I have mentioned that MIDAS nGen can be used very quickly for the irregular shaped members. We can use the software for curved slabs or the curved walls, and even the curved shells can be modeled quite easily. So here you can see that how the software provides an interface for the curved members here, and a much convenient thing about the software is that not only the generation of the members, but the editing of members is also very convenient. So we'll see this in the actual demonstration. And then, especially for the buildings, the program provides a CAD based input. Here you can see that there is an option called CAD Tracing, in which you can actually import the architectural drawing directly into the software. And you can just draw the certain windows, and based on the window, the program will generate the column sizes, column offsets, column locations, wall thicknesses, wall sizes, and it will automatically generate the entire model for you. And similarly, you can model the beams and sub beams quite easily. So we'll see this feature in the software itself, and we'll see that how we can actually generate the data quite easily. So let's move to MIDAS nGen. So here, this is the basic interface of the software. On the top, you will see that the software has various tabs, and these tabs actually run from left to right. So in the first tab, you have an option of importing the CAD tracing file. CAD tracing file is actually the architecture drawing file plus the layer information, that which layer belongs to beam, which layer belongs to column, and which layer belongs to wall. So CAD tracing means the architectural drawing with the layer information. So we'll see that how we can create this information. And then you have the various definitions, various properties of sections and story sets. Then you have the various member informations. You can generate various members in this tab. And then you have irregular geometry, or you can generate it using the body. Then you have various loads. So we'll see the details about the loads as well as the designs offered later in the session. And then you have the boundary conditions and various masses. And for the analysis, the program actually offers the various load combinations auto generation, and you can use these combinations for the design itself, and then you can generate the design results. You can generate various member shapes and various reports for the design, and you can even generate the drawings as I mentioned earlier. And then the program provides interface with various other softwares. You can bring in the data from other softwares, and you can even export the data from MIDAS nGen to other softwares. So let's see that how we can actually bring in the data from architectural file to MIDAS nGen. So for that, I'll just use this option called tracing file import. In the tracing file import, I will locate the tracing file or the architectural drawing which I want to import for this particular structure modeling. So here I'll generate the story data. So let's say I have 4 stories with height of 2.8 meter. Then I will link the archi drawing with the story data. So I have linked the archi drawing with 2 stories first floor and the second floor, and as soon as I click OK, the architectural drawing will be visible in the work environment. And here I have three views. I have 3D view, I have plane view, and I have story view. So depending upon what type of element I want to model, I can work in any one of these modes. So for example, I want to generate the columns and walls in the first story, so I'll switch to the first floor. Now we have this architectural drawing, and in this architectural drawing you can see that we have the entire information about the column sizes, column offsets, and we have the information about the wall, and even the beams are there. So let's see how we can quickly model this in MIDAS engine. So what we need to do is, first I'll generate the columns. For the columns, I'll select the column command and I'll choose the option create columns by select. So there are various options: by select, by 2 points, by 2 points, by 1 point, but I'll use this option called by select, and I will just draw a window from left top to right bottom. So now the program is identifying the column locations, column sizes, and column offsets. You will see that as soon as I click apply, the column sizes will be generated. So here, as soon as I click apply, I'll do it again. So here you will see that as soon as I click apply, the columns are generated. So there is no effort required for this. You just need a correct archi drawing. You can definitely change the column sizes later while designing the columns or even in the pre-processing mode. But in order to generate the columns quickly based on the archi drawing, you can use this CAD Tracing feature. Now here, if you want to generate the walls, then you can use the same thing. You can actually choose generate the wall by selection. So just draw a window from left top to right bottom or in any direction. Make sure that the window covers the location of the walls in the archi drawing, and as soon as you click apply, you will see that the program is detecting the location of the walls and it is generating the walls. So here we have the walls, and now the next thing that we want to do is we need to generate the columns. We need to generate the beams. So for the beams, I'll switch to story 2 and I'll choose the section for the beams and I'll choose the option by select. So this option by select will enable me to generate the beams very quickly, and I don't need to generate the beams one by one. So as soon as I click apply, the beams will be generated, and now we don't need to see the archi drawing, so we can just switch it off. So here we have the model with us, and now we want to generate the slabs. We can use the same method. We can use this by select option, and as soon as you draw a window, the program will detect the slab locations and it will generate the geometry of the slabs, and you can click apply to finalize the slab locations. Now if you want to delete the slab or any other element from some locations, you can just select those locations, and based on your selection, the program will delete the slab information or any other object that you select. So I press delete here, and now I have deleted the slab information from the file that I wanted. Now before generating the story, I'll just merge and I'll use the intersect command once. It will just help me in making sure that any intersections, any unnecessary intersections in the model, they are removed. So now I'll move this model to the origin. So for that, I can actually hit Ctrl M from the keyboard. So as soon as I hit Ctrl M, the software triggers the move command, and using this option called select 2 points, I don't need to mention the distance manually. I can just click on the model here from where I want to move the model to the new point. The program will determine the distance and it will actually move the model by itself. So now we can copy this data do the above stories. So for that you can hit Control C from the keyboard, and if you want to copy the structure, let's say 3 times at a height of 2.8 meters, you can enter the distance and hit enter from the keyboard. So the data will be generated quite quickly. So here you can see that we have actually generated the data very easily. Now let's say if you want to generate the grid for the structure, you can use this command orthogrid generator, and you can just click on extract based on if you want to generate the individual grid lines for the beams, columns, sub-beams, sub-columns, or the plates. So here, as soon as I click extract, the program will give me a preview of the suggested grid. If you want to edit, you can edit it. Otherwise, you can just click on OK and accept the grid. Now let's see how we can actually use this grid in order to modify the data in our model. So if you want to modify the data in our model, you can go to this member command, and in the member command we have this option called dimension. So here, as soon as I use this tool called dimension and I click on the grid will show me the dimensions of the entire model. So now let's say my intention is that I want to change the spacing of the first bay from 7.8 meter to 9 meters. So let's see how we can use this dimension. So here you will see that the dimension is mentioned using an arrowhead and a dimension number. So if I click this arrowhead will turn into another direction, and I can double click on the number and I can edit this number. So let's say if I want to change the dimension from 7.8 to 9 meters, so I'll just write 9 and hit enter from the keyboard. So as soon as I do that, you will see that the column along with the beams and the slab, it will move, and very easily I can actually edit this entire information. And if you want to call back the tracing set, you can just use Control T. It will call back the tracing or the architecture drawing back into the project, and you can use Control T to hide back the architecture drawing. Similarly, you can hide back the grids as well if you want to. And if you want to hide the dimension, you can just click on the dimension once again, and it will hide the entire dimensions from your model. So now let's see that if we don't have this archi drawing, if we want to start modeling our structure from scratch in MIDAS engine, then how we can actually do it. So in order to do that, I'll just open a new file. And we will see that how, without using an architectural drawing, we can actually model the structure in MIDAS engine from scratch. I'll just close the previous project. I'll save this project as project 2. Now, talking about the section properties, MIDAS engine provides actually a very smart wizard for the generation of the section properties. All the basic steel section properties, they are actually available in the software. Various databases are available. You can just choose which database, which shape, and which section you want to use, and you can use it very quickly. Along with that, the program actually solves the problem of combined sections very effectively. So here you can see that you can generate any of the templates for the combined section. Whatever section shape you want to use, you can generate any of the templates in the software, and you can edit the dimensions using a very intuitive graphic interface. Not only for the steel sections, even in RC, if you are using any different shapes, you can generate the template for any of these shapes. And then the program supports auto generation of the member offsets. You need not choose member offset for every member one by one. So the program provides various automated options for the generation of the member offset, using which you can actually generate the offsets for the entire structure at once. And then we will come to the modeling features for the slabs. We'll see that how the program provides various options for generating the slab openings and how we can actually model or edit the slab openings later. So the first thing that I want to do is I want to add the grids. So in order to generate a grid, you can just click on the grid and you can click on add button. So here you can specify the spacing for the grid. So let's say I want two bays at 4.5 meters, then I want another bay at 6 meters, then I want two bays again at 4.5 meters. You can enter this data. In the perpendicular direction, I'm looking for four bays at 5.5 meters, and for the height, I'm looking for 4 stories at a distance of 2.75 meters. So just enter this data and hit enter. The program will generate a grid for you. Now I will switch to this plane. Now the program has restricted me to work only and only in this plane. So for example, if I want to model the beams, I can just go to the member and I can go to beam. In the beam, I can choose the section shape that I want to. So here, if we have this section shape, I can just generate the beam. So here I'll generate a beam in X as well as the Y direction. Then I'll just copy these beams using the 2-point method. So here you can see that we have this 2-point method, and I can just click on the initial and the final location, and the program will keep copying the data to the new locations. Similarly, for this perpendicular beam, I can just use Control C and the 2-point location, and the program will keep copying the beam data to the new location. So moving back to 3D, I have this frame and I can copy in the perpendicular direction, in the vertical direction. I'll just use Control C and I will specify that I want to copy the data using the select curve or edge method. So I've selected the z-axis for the copy, and for the copy I'll specify the distance manually. So the idea is the program provides various options, and here I'll use this orthogonal constraint. Using this constraint, the program will enable me to draw only and only in the orthogonal direction. So for example, now if I want to model the data in this plane, then I can go to the plane and I can switch to the plane view. So I can generate the columns. So for columns, I'll use the concrete sections. So I can generate the data quite easily. And if you want to copy this, then again you can copy using the 2-point method in the plane view as well. So now one of the advantages of the plane view is that if you want to model some bracings or anything, then you can keep working in the plane view. You can work in the plane in any direction. So maybe if you want to work in the vertical plane, then you can just choose the vertical plane. And when you want to generate the bracings or the slanted beams, you can just use the vertical plane, and then you can keep on generating the data along any direction. So here I'll zoom in. So in the vertical plane, you can generate the data quite easily, and if you have slanting beams or bracing, then you can model the data very easily. So that's one of the inconveniences of the object-based softwares, which has been solved by MIDAS nGen very easily. So now I'll switch off the beam members so that I can copy the columns quite easily. So I've selected all the columns and I press Ctrl C from the keyboard, and then using this 2-point method, I can copy the columns in the further directions. And I'll hide the grid now since I don't need to use the grid anymore. And I'll just use the intersect command once in order to make sure that all the beams are intersected by the columns and the beams in the perpendicular directions. So here we have the structure now. Now the next step is that we should actually generate the slabs. So for the slabs, so for the slabs, I'll just use the slab. For slab, the program provides the membrane as well as the plate type behavior. If you want to generate the membrane slab, you can just choose membrane, and then you can draw a window and the program will auto intersect the edges and generate the plates for you. You don't need to do it one by one. Based on the frame, the program will generate the slab elements. Now, as I mentioned earlier, that we will discuss about the generation of the slab openings. So we'll see that how this software will actually help us in generating the slab openings quite easily, and how the behavior of the slab will change as soon as we generate the opening in it. So there are various methods for generating the openings. The first is that we can go to this body tab and we can generate the shape of the opening. So there are various options: line, point, circle, ellipse, or an arc. So you can generate the opening of any shape. So what you need to do is just create the geometry. I'll again check on the constraint mode so that it allows me to move my cursor only in the perpendicular direction. And here I created the shape of the opening, and then I'll go to the member and choose the opening, and using create opening by select, I click on apply and the opening is created. The another method for opening is create an opening by draw. In the opening by draw, you can just draw the shape and the program will generate the opening. Now similarly, you can use the dimension command in order to modify the opening. So let's say if you want to edit this opening, you want to edit this side of the opening, then you can just edit the number from 2.8 to whatever you want. So let's say 3. So the opening will be edited in the real time. So here we have our model in which we have created an opening. So as we have seen that we can generate the slanted members, slanted beams or slanted columns very easily, and the bracing can be generated very easily. For bracing, steel bracing, the program offers tension only elements, so we can use the tension only elements for the steel bracing. Now let's see that how we can actually generate the slab at different levels for one story. So in order to do that, I'll just delete this slab. So instead of this slab, I'll generate another slab which will be at different location. So I've just deleted this slab. Now if I want to generate another slab here which is bit lower, then I can use this option called plate beam. I'll specify the thickness of the plate beam. So actually plate beam is a new type of element which is supported by nGen. So here what you can do is you can just generate a plate beam and we'll see that how we can model this slab at varying location using the plate beam. So here we have these plate beams, and if you want to model the slab here, you can use the option slab, and this time we should choose the option slab by draw. So you can just draw the slab at a different location. So here I'll generate the slab. So I'm going again to the slab and using this option generate by draw. I'll generate the slab. So here you can see that as soon as you click, the slab is generated, and this slab is located at a different level. And this slab is located at different level, and these two slabs, they are connected by one beam element. So if I click show only, you can see that these slabs, they are connected to one beam element and they are located at different levels. So this provides quite a lot of conveniences in order to model such type of members. And then if you want to generate the curved members, even then generation of the curved members is quite easy. So we'll see that how we can actually model a curved wall or a curved slab or a beam element. We'll see a short demonstration of modeling of the curved members. in order to generate a curved member, what you can do is you can actually keep working in a plane and then generate the shape of the curved member. So for example, I want to generate a curved beam in this plane. So I've just switched to that plane, and you can go to the tab body and you can choose generation of arc by center point. There are various methods available. You can use any of the methods, but here I've just used generation by center point. So here we can generate the arc very easily, and again using the same method, generation of arc by center point, we can generate the another arc and specify the angle as 90, and then we can connect these two arcs by using the line element. So here I've generated this arc. Okay, so now what we can do is we can convert this body into the member. In order to convert this member, we have this option called convert to member. We can choose which type of member we want and what section shape we want. So here I've used this section shape, and as soon as I click OK, the member will be converted. So here you can see that how easily we can generate the curved element. We don't need to divide the curved element into various small segments. Instead, we can model the curved element itself. Now we can extend this curved beam to the curved wall. So let's see how we can do it. So for example, I want to generate a curved wall of the same shape. You can draw any shape for the curved wall. So here, let's say I want to generate a curved wall using this shape. So I can just select it and then I can use the option extrude. In the option extrude, I need to select the direction, and I can just drag this arrow, and when I reach my required height, I can just click on apply. So this is the plate element now. What you need to do is you need to select it, and then using convert to member, you can convert it to plate. So any shape of wall, it can be easily generated, and you can later convert it into plate, and you can perform the analysis and design using that particular element. So now here we will delete this curved wall from our model. Now the next step that we have is the generation of the loads. So we'll apply various loads into the model, and we'll see that how we can easily take care of the entire loading requirements for any type of code and any type of structure. So for that, I will create various load cases. So the first load is the dead load, and the second one is superimposed dead load, and the third one is live load. So I'll just create these load cases, and for the dead load, I will just create a new load case. So I'll just specify the direction of the dead load, and the program will auto calculate the cell weight for each and every element, and it will apply it in the model. So the cell weight is applied, and the next thing that we want to apply is the slab load. So for the slab load, we can actually create a set for the slab load, in which will include dead load, SIDL, as well as the live load. So I just find it convenient to change the unit before applying the slab load. So if I create it in kilonewton meter, then it's more convenient. So you can change the units very easily from the right bottom, and we'll create a set of load cases for the slab load. So here I have dead load, and I'll specify the dead load and the SIDL and the live load. So I've generated the slab load type, and I will assign the slab load. In order to assign the slab load, you can select the entire slabs at once, and as soon as you click apply, the slab load will be assigned. And I will save the model once again in order to not lose the progress. So we have applied the dead load and the slab load, and now we can move to the lateral loads. So if you want to generate the wind loads, we'll see that what options the program is providing. So I'll directly go to the assigned wind load, and from there I can call the definition command. So the program actually offers the wind load for the enclosed area, for the open structure, and for the equipment loading. and for the building structures. We should actually use the wind load for the building structures, but we will just see the application of the wind load for open structure in the software. So here what we need to do is we need to generate the wind load function. The wind load function can be generated based on the various codes, and you can see the variation of the wind pressure with the height. And in order to generate the open structure wind load, we need to select the objects in the direction of the wind as well as the ortho direction. So here you can see that for the open structure wind load, how the program has actually calculated the wind load based on the exposed area and how it is actually applied as a beam load to the various beam as well as the column members. So this is very useful for the industrial structures where we want to apply the wind load not on the base of diaphragm, but actually on the base of the steel members. But for this structure, we should actually use the wind load for the structure. So I'll delete this wind load and I will generate the wind load based on the story information. So for that, I need to generate the stories first. So here we can use the auto generate story data. And if I go to the load and I click on assign wind load, I'll go for the story option this time. And the design wind load, it will be as per Eurocode. So as soon as I click apply, the program will calculate the wind load based on the diaphragm and the exposed area in the X as well as the Y direction. Now the next thing is the seismic load. So for the seismic load, first we should assign the mass to the structure. We can actually use the auto conversion of load to mass. So we'll use the auto conversion of load to mass and we will assign this as the mass for the seismic action. So for the seismic load, you can directly go to the seismic load, and again we have two options, general structure as well as the building structure. We'll use the building structure here, and for the seismic action we'll use the Eurocode, and the program is able to calculate the period for the seismic action by itself, and we can just click OK and the program will apply the seismic action. So if you want to see any of the profiles of the lateral loads, you can just click on the show profile and you can see the story force, story shear and overturning moment in major as well as the ortho direction in the form of graph as well as in the form of Excel. And if you want to view any load, you can just click on the arrow in front of the name of the load and the program will show that particular load in the graphic view. Now, as I mentioned that the program offers membrane as well as the plate type of slabs. So let's say if we want to change these slabs into the plate types, then we can just select these 4 slabs, and in the properties we can change the slab from membrane to plate. So the program will change the slabs to plate type, and you can see that based on the color how easily we can identify that these are the 2 different slab types. Moreover, there are various other slabs in the model which cannot be actually membrane type. For example, this slab and this slab, they cannot be membrane type, they have to be plate type because they are not rectangular or square. So we have just modeled it and the program will automatically convert these slabs to plate type while performing the analysis. And if I go to load, there is another option being offered by the program which is known as the slab load transfer. So let's see how we can actually use the slab load transfer module. So just going through the PPT, we have seen that how we can actually generate the wind load for the building, enclosed, open as well as the equipments, and similarly how easily we can generate the various seismic loads. So now let's see that what is this slab load transfer. So in the slab load transfer, what the program is going to do is that the program will transfer the load from the plate type of slabs to the supporting beams and the supporting walls. So here, as soon as I click OK, the program will convert the load from the slab to the supporting beams or the walls. The benefit of this slab load transfer is that, for example, if we are dealing with a very high-rise structure and we need to actually reduce the analysis time. So how we can do is, we can actually use the slab load transfer. We can distribute the slab load from the slab to the supporting beams and the walls, and then we can actually remove the slab from our model. So whatever shape of slab it is it rectangular, irregular, with openings, without openings, whatever load it is, the program will actually distribute this load from the slab to the adjacent beams and the walls, and after that you can actually remove the slab from the model. It will reduce the number of elements in your model, and you can just reduce the analysis time very drastically. So here you can see that as we run this slab load transfer module, the program actually converted all these slabs into the plate type, since they cannot be supported in the membrane because they are not rectangular, or they are actually connected to the plate beam. So the program converted these plates into the plate type, and after that we'll be actually able to perform the analysis. Now another thing for the load for the plant structures, what the program supports is the crane load. So here you can actually define a crane and you can apply the crane load very easily. You need not apply the nodal loads in order to simulate the crane. You can just run the crane load and you can see that what is the optimum design force for the crane loads. So now the next thing that we need to do is we need to generate the boundary conditions. So for that I'll go to the boundary condition tab, and in the support I'll use what type of supports I want to generate, and moving to the front view I'll select the columns, and as soon as I click OK, the boundaries will be assigned. So moving back to the 3D view, I have the entire model with me, and I'll just switch off the bodies from my model, and if you want you can even switch off the entire reference tools. So now we have this model and we have actually assigned all the geometry, loads and boundary conditions, so we can actually run the analysis. For running the analysis, the program allows you to choose all the load cases at once, or you can even choose specific load cases to be run for the purpose of analysis. So here we'll use all the load cases for the analysis, and I've specified the analysis case. So I've selected all the members and all the loads, and as soon as I click on analysis, the program will perform the analysis. So the program is performing the meshing for the structure. And one thing that we can control is the meshing size. So we can specify the meshing in terms of divisions, in terms of length for each and every element. And based on that, the program will mesh the structure and it will calculate the behavior of the structure and it will provide us the results. So just to show the meshing. So here we can see that for 1D elements, I actually used the meshing method as division and I specified one division. So in order to make the data more accurate, I'll specify a mesh using the length method, and the length will be 0.5 meters. So if I click OK, the program will give me a warning message that the analysis results will be deleted, which is quite acceptable to me because I'm changing the parameters here. And if I run the analysis again, the program will again run the analysis using the new parameters. So after this, we'll move forward to generate the load combinations and perform the design for the structure. So here we have the analysis model with us. And if you want to see the various data, you can just quickly see the any type of information from this. And if you prefer to not to see the slab, you can switch off the slab. And for the analysis results, you can go to the any of the load cases that you wish to see. And for the dead load, for example, if you want to see the deformed shapes, you can just use the deformed shape. Okay, so here it seems that the model was. So now let's check the deformation results. And in the deformation results, you can browse to any of the load cases that you wish to. If you do not select the particular load case from here, you can even select from the drop down menu here. So for the reactions and the deformation results, you can go here, and if you click to any of the particular deformations, you can just check the deformations in the form of a graphic, contours, as well as in the form of a legend. Now here, if you want to see the beam forces, you can go to the beam forces, and let's say you want to see the axial force. You can just switch to the axial force, and similarly you can see the bending moment diagrams just by clicking on the particular thing and by checking on the various load cases. So now let's use this display initialize so that we come back to the initial data, and I'll switch on the slabs again in order to see the slabs in my model view. Yes, so now let's move forward for the design part. So in the design settings, we can actually use reset by program, and I'll choose the Eurocode. And for the checking as well as the rebar, so we'll use the Eurocode. And all these spacings, they're actually present in the software by default. And if you want to accept all these spacing, you can just click on OK, and all these settings will be recalled in the model file. And for the generation of the load combinations, the program offers the auto generation of the load combinations using the various codes. So here we'll use the Eurocode for the generation of the load combination, since we are using the Eurocode for the design. So here we have the various load cases and the load combinations. So we'll use these load combinations for the design, and you can switch to the spreadsheet view if you want to copy paste the load combinations from Microsoft Excel. And then we need to assign the design group. To assign the design group, we can use this option auto generate design group. In the assign design group, we can just use the auto select and click on all. The program will generate the design groups based on the various section sizes then. And then when we want to run the design, we can define the design case. In the design case, we can choose which load case and for which members we want to design. And once I click OK, the program will create a design case here. And then in order to run the design, you can click on run all. So if I move to the post-processing mode, I don't need to run the analysis again. I can just use the run design option. So here for the design, the program actually provides various options. Let's see that what are the various options for the design. So moving from analysis to the design, the program actually supports the target ratio based design. So here you can see that you can specify the target ratio, and based on that ratio the program will perform the design. So you can specify the target ratio for ultimate strength or for serviceability, and while performing the design, while calculating the required rebar, the program will use those particular ratios. And then the program can also perform the optimal design. The program can find out the optimum section size for the steel, as well as the program can find out the optimum rebar placement for the concrete. Along with that, the program can even vary the section size for the RC, and based on the various requirements for serviceability, ultimate state, the cost of the structure based on the various cost data we input. The program can optimize all these three things, and we can obtain the results which satisfy all the three criteria and what are the most optimum results. So we'll see that how we can specify that data. So if you want to optimize RC section, we should actually check on RC section, and here you can see that we can specify the various requirements for the section size and the serviceability, and for the price evaluation we can specify the data for the price, and once I click OK, the program will perform the optimization of the RC section. If one size of the beam is not optimum, the target ratios are not met, the program will use the RC section optimization and it will use it for the structural design. But if you don't want to change the size of the beam by the program, then you can just check off and you can check on the rebar arrangement. When I check on the rebar arrangement, the program will find out various combinations for the rebar which actually provide us the optimum design of RC sections. Now if I click OK, the program will start performing the design. And now the program is performing the design for RC as well as the steel members. Along with that, the program actually supports the design of membrane slabs. So if we have membrane type slab, if we have one-way or the two-way slab, then the program can perform the design of such slabs in one step. We don't need to use various other steps. The program can perform the design for plate type slabs, and it can perform the design for membrane type slabs. So one of the very big inconveniences is removed using MIDAS nGen. Earlier we used to take out the data from the 3D software to the spreadsheets or other 2D based softwares for the design of membrane slabs. But here, since everything is integrated, the program will perform the design for membrane slabs as well. And the design is completed. If I click on status, you can review the results for the design. So here you can see that the various slabs, they are in red, and the various beams and the columns, they are in blue. So we can match it with the legend, and if you want to see the design report, you can just choose the various members for which you want to see the design report, and you can click on the design report. So various options are available for the design report format. There is a summary report as well as there is a detailed report. So let's say if we want a summary report, then we can generate the design report for this beam. So Word format of the summary report will be generated. So here you can see that the summary report is generated very easily. And for the membrane slab, since all the slabs are membrane slabs, so you can just choose the slab and perform the design and generate the Word report for the design. So the membrane slab will be designed based on the Eurocode, and you can see the various outputs in the report. Along with that, you can even see the design for RC columns. So here, if you want to see the design report for the RC column, you can just go to design report, and the program will give you the design report for the RC column. So you can generate the report for the entire structure at once, or you can even generate it one by one. It's totally up to you. But this status, it actually helps us to identify that what are the critical members and what are the good members and what are the failed members. So all the information, it can be obtained quite easily. So here we have an information in the form of Word file. So we can generate the design report and we can generate the project report. So for the project report, the program actually supports in-house word processor. So the program has an in-house word processor for the project reports, and you need not use Microsoft Word for that. And then we can generate the drawings in the user-defined template. We can just define a template and the program will generate the drawings using that template. So I'll just save the model and I will move to the presentation now. So here, let's see that for what type of projects can MIDAS nGen be used. So MIDAS nGen can be easily used for irregular structures. So if we have a very complicated shape and we are finding it difficult to model the shape in AutoCAD or in any of the object or the node element based software, then we can actually use MIDAS nGen for that. And it is very convenient to model nGen. It is very convenient to model any type of structure using nGen. So if you have the odd shaped structures which are quite difficult to model, then nGen can solve the problem quite easily. And moreover, if you have a structure in which you have a common base and then two towers are supported on the common base, then nGen can be used for it quite easily. Similarly, for the plant structures or refinery frames or the various other irregular shapes, stadiums. So MIDAS nGen can be used. So how we have seen that starting directly from the architectural drawing, we can model the structure very quickly and we can apply the various types of loads. It provides the load conditions for almost every type of structure. That's what MIDAS planning team has taken care of. And then we can generate the drawings and we can create the design reports for almost all the type of members. So in this way, MIDAS nGen actually provides a new working environment, which is the object based and for the irregular structures. And in this video, we have seen that how we can actually use MIDAS nGen to model any type of structure. So thank you for attending today's session. If you have any question, you can write down the questions to info@midasit.com.